Hi there. Our next lesson is going to be on graphing from standard form. So far in this unit on slope, we've talked about how to find slope from a line. So that means that we're looking at a graph and it gives us a line. What we know are points. There are lots of different points on that graph. And so if we find two of the points, we can use that to find slope. We can go rise over run, so elevator up or elevator down. Elevator goes up, it's positive. Elevator goes down, it's negative. So we go rise over run, and we can write our slope. We also did slope from 2 points, and that's where we talked about the formula of y2 minus y1, x2 minus x1, the double rainbow. So it's y minus y, x minus x, write them as a fraction and simplify. Remember that subtraction turns into addition where we add the opposite. That's what we've covered so far this week. Today we're going to add the piece of graphing from standard form. So standard form, in your notes, write this formula. It's ax plus by equals c. That is what standard form looks like. So if we plug some numbers in there, we have things like 3x plus 6y equals 18. Okay? That is not typically the form that we like our equations to be in. We usually like to solve for y and have y on one side and have the other things on the other side, have it be in a two-step equation form. It's what we're comfortable with. It's what we've done a lot so far this year. But sometimes in graphing slope, standard form is a really convenient and handy form to have it in. So when you see an equation in this form, you need to, one, recognize that that is called standard form. Now you're going to be asked to graph from that. And when you're asked to graph from that, what we've done in the past is we've done things like we've made a table, x and y, and then we said, okay, we can plug values in for there, right? We could put in all different kinds of numbers in here, and we could plug those numbers in for x, and then we could solve that equation, and we would end up with different values for y. And we could certainly do that again, but gosh, it's going to take us a long time to do that, isn't it? So let me show you a shortcut. Let me show you an easier way to do that. We're still going to use a table, but we're going to call it kind of a baby table, x, y. We're only going to need 2 points. That's it. Because when I graph a line, any line, let's say that I'm graphing this line right here. When I graph that line, it's going to have a spot where it crosses the y-intercept. Remember, this is our y-axis right here. So it's going to have a spot where it crosses the y-axis, and it's going to have a spot where it crosses the x-axis right here. This is our x-axis. So that line is going to have two very important spots that we're going to pay attention to in this particular situation. Where does that line cross the y-axis? It's called the y-intercept. And where does it cross the x-axis? It's called the x-intercept. So these spots right here are called intercepts. Okay? This one right here is the x-intercept, and this one right here is the y-intercept. Okay? Well, so using that, we can make like a little baby table. We can make a small table. So if it's crossing the x-axis right here, x is going to have some value, right? Some number that it's going to be. And what's the y value going to be for this spot right here? Y will equal 0, right? So no matter what x is, y will be 0 at that particular point in time. What about this dot right here? Where it crosses the y-intercept, y will have some value, y will have some number associated to it, but what will the x be? The x will always be 0 in that case. So if I can find those 2 points, the point where y is 0, that's the x-intercept, and the point where x is 0, that's the y-intercept, I can graph this line. Now, 0 is a powerful number in algebra, right? Because 0 is the magic eraser. 0 makes things go away. So watch what happens with this. If I take that x, 0 is x, and I plug it into there, I get 3 times 0 plus 6y equals 18. Becomes a magic eraser, right? This just goes away, and I'm left with 6y equals 18. That's a one-step equation. Divide both by 6, I get y equals 3. So if x is 0, y is 3. The y-intercept is 3. Pretty easy, right? Let's flip it around and do the other way. Let's take where y is 0 and watch what happens. So when y is 0, let's take that 0, put it right there. So I get 3x plus 6 times 0 equals 18. Multiplying by 0 is the great eraser. That's going to go away. I'm left with 3x equals 18. Divide both sides by 3, I get x equals 6. So when y is 0, x is 6. And if I have just those 2 points, I can graph the whole line. Because from my graph, I'm going to go where x is 6, which is going to be about here, and where y is 3, it's going to be about there, and I can graph my line, it's going to look something like that. All right, let's take a look at a couple of other examples. See if I can flip pages over here. Oh, it's not going to let me switch forms. Well, let me grab my paper, and I'll just write them up here for you. All right. X plus 2y. Apparently, I can only record on one tab. X plus 2y equals 18. All right. So if this is what I'm going to do, I can use my baby table, my x and my y. So I'm looking for is where x is 0 and where y is 0, my two values, right? So if x is 0, you put that 0 in right here. So basically, I can just cover up that x. If you just take like your hand and just cover up the x part of it, so just cover up this part of it right here, you're left with 2y equals 18. 2y equals 18, that means if x is 0, y is 9. Take the same equation, x plus 2y equals 18, but this time put y as 0, put the 0 in there. If you put a 0 in there, you can basically like take your hand and you can cover up the 2y spot. Just cover that right up. Just cover up the 2y. You're left with x equals 18. So I know that y is 9 and x is 18. So if I graph that, x is 18, it's going to be a point out here. Y is 9, it's going to be a point out about right here. And I can guesstimate, it'd be right there. So without graph paper, I can make my best estimate. I know that 9 is half of 18. So this point over here on the x-axis should be twice the distance of wherever I put it on the y-axis, because 18 is twice of 9. All right, pretty easy, right? Let's try a couple more examples. What about if I have 3x minus y equals 9? 3x minus y equals 9. All right, well, if x is 0, if you put a 0 right here, right? Put a 0 right there, just cover that up. Cover it up, you get negative y equals 9, which is y equals negative 9. So my y-intercept will be negative 9. Do the same thing for the y being 0. Right? If the y is 0, if you're putting a 0 in that value right there, it's going to cancel this all out. We're left with 3x equals 9. You can just cover up the y. If I'm solving for x, I cover up y. If I'm solving for y, I cover up x. Opposite one, this will be x equals 3. So what I just have to do is plot those 2 points on my graph. So if I have x is 3 and y is negative 9, my graph is going to look something like that. Right? Not a hard skill. Not a hard skill, right? Look at 4 more. 5x plus y equals 30. And if you're in class, you'll have these in your notes. I'll give you like a little paper to put these on for your notes. Okay, so put a 0 in for x. Put a 0 in for x, and y will then equal 30. Right? Because if I put a 0 in here, it's going to erase that and make that go away. Right? So it's going to get y equals 30. Take the same thing, negative 5x plus y equals 30, but put the 0 in right here. So it covers up the y, makes it go away, and we get negative 5x equals 30, which x equals negative 6. So our intercepts are x is negative 6 and y is 30. So if we graph that, x is negative 6 will be a point over here, and y is 30 will be a point up high. So our graph will look something like that. All right, 3 more. Negative 6x plus 3y equals negative 9. Cover up the x and solve for y. You get 3y equals negative 9. Like my hand is literally just covering up the negative 6x. I'm just hiding that from my sight. 3y equals 9. I get y equals negative 3. Now with my hand, I'm going to cover up the other. I'm going to cover up the 3y. So I cover up the 3y. And what I see is negative 6x equals negative 9. So divide both by negative 6. I get x equals negative 9 over negative 6, which is going to be a positive 3/2 when I simplify. Right? So these are my intercepts, my x-intercept and my y-intercept. So from standard form, we are given the x-intercept and the y-intercept. If I have the x-intercept and the y-intercept, I can graph. Right, and 2 more. 4x plus 12y equals negative 18. You give this one a try and see what you get. All right, you try it on your own first. Definitely recommend you do that, then check. So if I cover up the x, cover up the 4x, I'm left with 12y equals negative 18. So I get y equals negative 18 divided by 12. And if I simplify that, then that becomes negative, what goes in there? 3 6/4. Oh, that reduces further. You can take 2, next 3/2. Oh, it's negative 3/2. So remember to simplify all the way down if you can. Next, cover up the y. Cover the y, you get 4x equals negative 18. Divide that by 4. Then this becomes x equals negative 9/2. Okay, so it's okay if there's fractions. It won't happen very often, but sometimes there will be fractions that it's okay. And the last one to show you, 9x minus 6y equals negative 72. So here we're going to cover up the x. We get negative 6y equals negative 72. Divide that. You get 72 divided by 6. Did you do that one on your own? My fingers are fumbling today. Divided by 6 is 12. So y equals, it'd be positive 12. If we do it the other way around and we cover up the y, then we get x equals negative 8 for our intercepts. And all we gotta do is graph that then. X is negative 8, y is 12, and our line will look something like that. All right, there you go. Have a great day.